Chapter 11, Part 2 of Crystals, Ions, and Solutions. Now, dissociation. Dissociation, Dissociation, refers to the separation of a compound into ions when it dissolves in water. So, the ions of the material dissociates when it dissolves in water. Electrolytes now. Electrolytes of substance that dissociates into ions when dissolved in water. Electrolytes in solution are capable of conducting electrical current. So there are non-electrolytes and there are electrolytes. And electrolytes are the kind that dissociates when it's dissolved in water. Non-electrolytes, as I just said, are soluble covalent compounds that do not dissociate in solution, particularly water solution. Ions in solution. Ions in solution have their own set of properties that differs from their original atoms and from the original solutes. Dissociation is a type of chemical change. Secondly, the property of a solution of an electrolyte are the sum of the properties of the ions present in the solution. Go on. Water. Let's talk about water in general for a minute. Water covers about 3/4 of the Earth's surface, and seawater, which is what most of the water on the planet is, seawater has an average salt content or salinity of 3.5. These are some of the constituent ions that you will find in water. The chloride iron, sulfate iron, the bicarbonate here, the potassium, the calcium and iron, magnesium, and the sodium iron. All these different irons are found in any part of seawater. Hard water. Hard water, as you know from experience, plug up or stop pipes in your home. They will clog up an iron that you use to smooth out clothing. So what are the constituents that lead to hard water? Hard water is fresh water that contains the calcium 2 plus and or the magnesium 2 plus iron in solution. Here's a case. If you now have calcium carbonate gets mixed with carbon dioxide and water, it will generate this uh, this this calcium iron, calcium 2 plus, and the bicarbonate iron. This equation is chemically balanced, but the most important thing is we get the calcium 2 plus ion in solution, and we get this bicarbonate iron in solution. Salt water is free of this calcium 2 plus iron. A similar type reaction will yield the magnesium 2 plus iron. Acids now. So we're going to talk about acid, bases, and salts. An acid is a hydrogen containing substance that increase the number of hydrogen ions, H plus ions, present when the solution is dissolved in water. So you must have the substance in water for it to be an acid, okay? And this H plus ion release when an acid dissociates in water combines with a water molecule to produce the hydronium ion. So each of the H plus ion will combine with a water molecule to make this hydronium ion in water. That's simply because the hydrogen ion doesn't want to stay alone by itself. It has the inclination to bond with a water molecule. And there are so many water molecules present, so it's easy for that to occur. Further discussion on acids. The characteristic properties of acids are actually the properties of these hydronium ions, rather than the property of the hydrogen ions only. The water solution of acids tastes sour. The acids change the color of litmus dye from blue to red. This is a depiction of the hydronium ion. Three hydrogen ions bonded close to one oxygen ion makes for this hydronium ion. Strong and weak acids. Strong acids dissociates completely. That means separate all of the ions. S- uh, they dissociate completely. And some examples of strong acids are hydrochloric acid, HCl, sulfuric acid, H2SO4, and nitric acid, HNO3. Weak acids dissociate only slightly uh, when dissolved in water, and such as HC2H3O2, which is this acidic acid. Acidic solution. Some substance, such as carbon dioxide, do not contain hydrogen, but produce acidic solutions by the reaction with water to liberate the hydrogen ion from the water molecule. So you can simply combine a CO2 with water and you get hydrogen ion and this bicarbonate ion again. Further, the bicarbonate ion goes through another chemical reaction and yields more of the hydrogen ion and this CO3 2 negative ion. The mere fact that you have these hydrogen ions now that bond with another water molecule, you're going to get an acid solution. Bases. A base is a substance that contains the hydroxyl group and whose solution in water increase the number of the uh, hydroxyl ions present. HOH negative 1 ion present. Strong bases dissociate completely, weak bases dissociate only slightly. Here's a case now. Some substance such as ammonia do not contain the hydroxyl ion, but produce a basic solution because they react with water to release the OH ion from water, such as here. Pure ammonia will combine with water chemically and get the hydronium ion and this hydroxyl ion. And so this is ammonium, NH4 plus 1, and the hydroxyl ion, OH negative 1. The water solution of bases have a bitter taste, a soapy feel, and turn red litmus to blue. The name alkali is sometimes used for a substance that dissolves in water to give a basic solution. The term alkaline and basic means the same thing. Dissociation of water. Even pure water will slightly dissociate. So pure water dissociate very slightly into the the hydrogen ion and the hydroxyl ion. Only a few molecules out of several billion do this, but a few will dissociate in this manner. In an acidic solution, the concentration of the hydrogen ion is greater than that in pure water, and the concentration of the hydroxyl ion is lower. Just the opposite. In a basic solution, the concentration of the hydroxyl ions is greater than that in pure water, and the concentration of the hydrogen ions are lower. So come to this scale called the pH scale, and pH means power of hydrogen. The pH scale expresses the exact degree of acidity or basicity of a solution in terms of its hydrogen ion concentration. A solution that has neither solution that is neither acidic or basic is said to be neutral and has a pH of 7. An acidic solution that has a pH value less than 7 is an acidic solution, pH of 6, 5, pH of 4.5, etc., are acidic solution. And the smaller the number, the stronger the acidity. On the other hand, basic solution have a pH value of more than 7, 7.5, 8, 9, 10. Those, the higher the number, the greater the basicity of the solution. And this is a scale that depicts that. Coming to the left, here the pH of 0 all the way pH of 14. On this side of 7, strong base material. On the low side of 7, strong acidic material. The pH concentration, a change in pH by 1 mean a change of hydrogen ions concentration by a factor of 10. So as the pH goes, say, from 4 to 3, now you have 10 times more hydrogen ion in the solution than you had in the first case. And it continues in that manner. This is another depiction of pH for common substances, with pure water being right at the middle at pH of 7. Acidic solutions are, are to the top, and basic solution to the bottom. Notice that battery acid, gastric fluids, um, have a very low pH value, and these are strong acids. Vinegar is here. Soft drinks, beer have a fairly strong acid solution as well. Coffee, tea, urine, etc. Even saliva is an acid material. Seawater, baking soda, soap are all basic. Even oven cleaner is a basic, as well as hair remover. Now, what happens when you mix a strong acid, HCl, let's say, with a strong base, sodium hydroxide? Notice what happened. You get H2O, water, and you get the chlorine and the hydrogen ion in solution. Now, so really what has happened in this neutralization process, uh, the hydrogen ion will combine with the hydroxyl ion and create water from that, combine to make water. So when a salt solution is mixed with an acidic solution, the base destroys or neutralizes the properties of the acid and vice versa. The process is called neutralization. In neutralization reaction, the hydrogen ion and the hydroxyl ion join to form water molecules. And so the salt that's left once the evaporation, this is the way that we can get salt. Most salts are crystalline solids that consist of positive ions and negative non-metal ions. This is all for this presentation.